What if I told you that inside every single bird you've ever seen, there's a hidden biography, a detailed record of its entire life, etched right into its bones? Well, today we're going to learn how to read that story, a story that connects it all the way back to ancient dinosaurs and, believe it or not, even inspires the future of our own technology. We all know this sight, right? The vibrant, living bird, full of color and motion. But underneath all those feathers lies the architectural masterpiece that makes it all possible. And that intricate skeleton, it's not just a frame. It's a life story written in bone. And today, we're going to figure out how to read it. Okay, so first, we've got to change how we think about skeletons. Forget all the spooky, static things you see in museums. These bones are dynamic records. They're like keys that unlock the entire dramatic story of one animal's life. That's it, exactly. Every single skeleton tells a unique story. A healed fracture could be a clue, evidence of a close call with a predator. The density of the bone might reveal its diet or its health. It's a literal, physical record of that one bird's own personal struggles and its triumphs. So this brings up a pretty interesting question, doesn't it? How in the world do we get from a living, feathered bird to one of these perfectly preserved skeletons? Well, it's a process that takes an incredible amount of skill, a ton of patience, and a deep, deep respect for the animal. The whole thing starts with ethics. That's non-negotiable. These specimens are sourced from birds that have died from natural causes, or they're provided by conservation groups. Then the really meticulous work begins, carefully removing tissue, cleaning the bones, and finally reassembling the whole thing like an incredibly complex 3D puzzle. And each one of these stages is a true art form. It's this slow, delicate practice that demands a deep, deep knowledge of anatomy to make sure every single tiny bone is put back exactly where it belongs. It's really about honoring the animal's life. Now, what makes this process so challenging is also one of nature's most brilliant inventions, pneumatic bones, basically hollow bones. But it's more amazing than that. Imagine a whole network of bones so hollow, they're actually part of the bird's breathing system, literally filled with air. This makes a skeleton that's unbelievably light, but still super strong. It's an absolute marvel for flight, but it also makes them incredibly fragile and really, really tough for specialists to work with. All right, so we know how they're prepared, but what stories are these skeletons actually telling us about a bird's day-to-day life? This right here is where the real detective work begins. This is the big question, isn't it? And the answers, well, they're etched into the shape and the structure of every single bone. They can tell us everything from what that bird ate for breakfast to how it escaped its enemies. The skull is just a perfect example of form following function. A finch's skull, it's thick, it's powerful, it's built to support a beak that can crush hard seeds. Now, compare that to a warbler's skull. It's delicate and it tapers to this super fine point. It's a precision tool for snatching insects right out of the air. The bird's whole diet is written directly into its anatomy. It's amazing. And the legs tell the exact same kind of story. You look at the massive, thick leg bones of an ostrich, and they are built for one thing: powerful, high-speed running. Now contrast that with a sparrow's delicate bones. They're engineered for agility, for securely gripping onto tiny branches. You've got two completely different lives, and so you get two completely different skeletal solutions. And it's not just about the individual bones, but how the entire system works in perfect harmony. By studying the complete skeleton, scientists can decode the secrets of balance and flight. And this isn't just for academics. This natural blueprint has directly inspired engineers to build more stable and more efficient drones. How cool is that? So, we've looked at an individual bird's life story. Now, let's zoom out. I mean, way out. Let's see how these skeletons tell the grand, sweeping story of evolution over millions and millions of years. This timeline really shows the epic journey. Skeletons let us trace the lineage of modern birds all the way back to their dinosaur ancestors. We can see these transitional fossils emerge. We can watch as giant species like the dodo and the moa appear and then just vanish. And we can witness the explosion of diversity that led to all the birds we see around us today. The Archaeopteryx fossil is the perfect case study for this. Its skeleton is this beautiful mosaic of old and new. I mean, it's got sharp teeth and a long bony tail straight out of its dinosaur heritage, but then it also has feathers and wings that are adapted for flight. It's evolution in action, caught in stone. Skeletons like this are absolutely priceless snapshots of life's history. So finally, this incredible diversity of shapes and sizes, It's not just fascinating to study, it really provides a beautiful blueprint for design and, honestly, a deeper understanding of life itself. This contrast just shows the absolute extremes of bird evolution. On one hand, you have the hummingbird, whose skeleton is this impossibly light marvel, engineered for insane aerial acrobatics. And then on the other end of the spectrum, you've got the ostrich, with a massive, robust skeleton built to support a huge body and generate incredible running power. And this brilliant natural engineering is so much more than just beautiful. It is a huge source of inspiration. That lightweight, hollow truss structure of bird bones, it's influenced aerospace design and the development of new, super strong, lightweight building materials. Nature, as it turns out, is the ultimate engineer. Yeah, and ultimately studying these intricate structures does way more than just teach us about birds. It connects us to the entire story of evolution. Each skeleton is a chapter in that story, a real testament to adaptation, to survival, and to the absolutely breathtaking ingenuity of the natural world. So, here's the big takeaway. The next time you see a bird, doesn't matter if it's landing on a branch or just soaring way overhead, take a second. Imagine that intricate, lightweight skeleton working away beneath the feathers, and just think about the incredible story it tells. I promise, the world around you might suddenly seem even more amazing.